Welcome to another tutorial of MATLAB. In this tutorial series, we are looking into the concept related to electric vehicle and hybrid electric vehicle. Overall, in this particular videos, we are looking into the charging infrastructure that we have. We also have a look into the proximity pilot. In this particular video, we will be having a look into the control pilot implementation. So for that, let's jump into the content. So as we already seen that we have a frequency generator which has around 1 kilohertz of frequency and plus to minus 12 volt in the case of control pilot. So if you see the circuit, control pilot pins are pin 4. So this is a pin that connects between the electric vehicle, the EVSE connector. So this is the part that is there for the EVSE connector, and this is the part that is there for the vehicle. And the pin 4 is responsible for the connects. In this case, we have 1K resistor, which is there on the EVSE side. We do have voltage detectors. So basically, this helps in measurement of the voltage that we will be implementing in a different way in the MATLAB environment. Along with that, if you see, we do have two more register, that is 2.74K register, that is the R3, and 1.3K register, that is the R2. And we do also have a diode connects just to prevent the backflow of current. Based on this circuit, we do have multiple stages, like whether the charger is connected or not. If it is connected, then we will be getting a 9 volt range of voltage. If we want to allow the current to flow, or we want to have the charging process enabled, then we will be having a 6 volt of pulse that is getting generated. So in this case, we will be getting these two voltage levels once the proximity pilot signals that the charger is connected, and we will be getting these voltage levels. The first one is charger is connected but not charging, and the second one is charger is connected and it is charging. So let's see the implementation for the same for the control pilot. So if you see over here, we have the same configuration in this case. So here we are measuring the voltage at multiple levels. So this is the source generator, which is basically generating a 12 volt supply with the 1000 hertz frequency. So this is the signal that is getting generated, and this is a control voltage source. So whatever the signal that is we are giving in this source port, right? So those will be coming as a voltage level in this area. And this is the status pin for the proximity pilot. So if it is 1, then only the entire process will work. If it is 0, then it will not work. So for this, we usually refer to the proximity pilot. So for proximity pilot, please have a look into the previous video for the tutorial series. And in that, you will be getting a detailed overview of the proximity pilot. Once that is complete, you come to this video and have a look how the control pilot works. So once the proximity pilot sends the signal as true that it is connected and the charger is connected to the electric vehicle, then this entire process will get activated. So because of this, we do have connected multiple registers. As we seen that we have 1K register. So this is the 1K register that we have, which is there on the EVSE connector. So this part till this point, it is the EVSE part, and this part is the electric vehicle part. So here we do have the 2.74K ohm resistance, and here we do have this 1300 1300 resistance, 1300 ohm resistance, and we are actually measuring the voltage levels between the line, as we already seen the detector stage, right? So after the detector, like the detector is present just after the 1K register. So in this case, we seen that after 1K register, we are just measuring the voltage. So this is just after the 1K register. This is the 1K register that we have, and it is connected to here. Basically, we are measuring the voltage across the terminal between these two terminals. One is the ground and another is the positive terminal. And here we are giving the reading. Along with that, we are sending it outside so that we will be knowing based on the status, like how it is getting operated. Along with that, we also have this charging needed or not, right? So that is one pin that is one option that is there. And if it is like needed, then only this this resistance will come into the picture, and the voltage will drop. Otherwise, the charging process will not start. So at that moment, the voltage will be 9 volt. So as in the previous case, in the proximity pilot, the voltage is not exactly equal to the required voltage, but it is somehow near it. So same way happens here as well. So let's see like how the control pilot works. So here, if you see, proximity pilot is sending a true value, which means it is connected. And along with that, we also need the charger to be connected. If the charger is not connected or the port is not connected, then we cannot operate the control pilot. So that is why we need to have those two values, the charger connection and the proximity pilot connection, as one. So if we start the simulation, now charging is not needed. The situation is there, charging is not needed. So you will be getting a voltage of around 6 volt. So this is around 6 volt. And if the charging is needed, then you will be okay. So you will be getting the output response here. So if you scale it, so you can see 6 volt is, it is sending the pulse of 6 volt. And if I just change the switch, the charging is not needed. And in that case, I will be getting a 9 volt supply, right? So I'm getting around 9 volt. The level is getting changed. If I just, so I will keep the components side by side so that you can see it properly. Keep it this side and the other one this side. So this is my overall connection. Now I'll just start the simulation. So you are getting the pulses. So it is 9 volt, and which means charging is not needed. We are not charging. If I switch it back again, then I'm getting a pulse of 6 volt, around 6 volt. And through this, what I'm basically telling that I want the charging process to happen. And if you see over here, if I just stop the simulation or pause the simulation, and I want to see the pulse width that is there needed. Okay, so we can see this is the pulse width that we are getting. So we can control the width of this pulse to get a defined amount of current, and through that we can control the current in the entire circuit, which is basically controlling the charging current for the electric vehicle from the charging port or from the charger. This is how the implementation looks like. And okay, in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. So happy learning MATLAB, stay connected. Thank you.